Hello everyone, my name is Luis Paredes and I'm excited to present on behalf of my research team FabHandWear, an end-to-end pipeline from design to fabrication of customized functional hand wearables. Hands have evolved into a universal and versatile tool to manipulate and sense objects. Within the HCI community, hands have been extensively used as means of user interaction. However, hand wearables are challenging to design and fabricate because of the anatomical variability, multiple degrees of freedom, and the absence of standard manufacturing techniques. We believe that a tool that can effectively adapt designs, size, geometry, and functions relative to the user's anatomy can address these issues. As previous systems have been too specific for a single wearable design, not scalable in terms of functionalities and components, designs only in two dimensions, or generalized for all body parts, which makes it challenging to adapt for the hands. We conducted a preliminary study with 10 participants to analyze and understand the impact that fitting has on the users and their experience while performing simple tasks as common as typing on a virtual keyboard displayed on a head-mounted display. From the study, we learned that the ratio between the hand and the wearable have a direct effect on the sensor location, the visual attention required for interactions, the attachment method of the wearable to the hand, and the need to adjust the location of the components. FabHandWear allows users from many knowledge levels and multidisciplinary backgrounds to explore and prototype new hand interaction, sensing, and input modalities. The web-based application allows users to input their hand parameters to create wearables that just fit right on their hands. Next, users attach a variety of components based on their desired functionality onto a 3D hand mesh. The user can place these components at any desired location and orientation of the hand, which allows them to control the shape of the substrate that will attach to their hand. FabHandWear's guided design workflow assists users that are not familiar with electronics or wearable design in multiple ways. A function-based component menu that allows users to find the suitable component quickly. Feedback prompts that suggest to the users the components that go together to achieve complete functionality. Automatic and manual routing with color-coded pins that do not require the user to go through long datasheets and complex wiring instructions. Finally, the system generates a fabrication file in the form of a 2D circuit layout that is ready to be printed. The pattern is transferred to the substrate fabric by screen printing using the conductive silver ink. This is followed by curing the ink in the oven for 5 minutes at 65 degrees Celsius. Next, the user places the components in their respective positions using C-conductive tape and paints the terminals with silver ink to ensure connectivity. Lastly, the user cuts the fabric along the substrate guides and sticks it to their hand using a skin-friendly adhesive tape. We evaluated our tool with a user study and through example applications that explore the feasibility, applicability, and potential of creativity. We built 4 models inspired by real-world, health, aesthetics, and science fiction applications. We showed customized hand wearables for cosplay, health monitoring, and interactions with emerging technologies. To evaluate the usability of the tool, we conducted a remote user study with 13 participants, where we asked them to design 3 models using FabHandWear. We hypothesized that participants will be able to implement the tasks using FabHandWear features simply and faster than manual procedures. During the tasks, the participants had to size the parametric hand model, place components, manually generate the circuit, and finish by generating a template. The results suggest that FabHandWear successfully allowed designers from different backgrounds and levels of expertise to design and create hand wearables. Participants were faster after each task was completed, and it was independent of the task complexity and the number of components. The simplicity of the tool allowed users to focus on the functionality desired, increasing the trust in designers with no engineering or technical backgrounds. For future work, we want to investigate the impact on more inclusive parametrization features, a multi-layer and multi-material manufacturing method, and opening the tool for general distribution. We believe that our research provides promising insights for the design of 3D wearables personalization systems that can enhance the development and prototyping of novel applications in new domains.